What if I told you there are fish out there who look at the concept of a fixed biological sex and go, not for me, thanks. Welcome to Zoodoodle, and today we're talking about sequential hermaphroditism, which sounds like a spell from a wizard movie, but is actually just fish doing whatever works best. You know Nemo, right? Sweet little orange fish, lost his mom, went on an adventure, very wholesome. Here's what the movie didn't tell you. In real clownfish colonies, there's a strict social hierarchy. At the top, a dominant female. Below her, a breeding male, and below him, a bunch of non-breeding males just hanging around living their best low-stress lives. Now here's where it gets interesting. If the female dies, the breeding male changes sex. He becomes she, fully female, hormonally, behaviorally, reproductively, the whole package. Then one of the non-breeding males steps up and becomes the new breeding male. So in the actual Finding Nemo story, after Nemo's mom died, his dad Marlin should have become Marlene, and Nemo would have eventually become his own father's husband. Pixar made the right call leaving that part out. Clownfish aren't the only ones doing this. Wrasse fish go in the opposite direction. They're born female, live their early lives as females, and then, if they grow big enough and bold enough, they transition into males. Bigger, brighter, more dominant males. This is called protogeny. Proto meaning first, gyne meaning female. Female first, male later. Clownfish do protandry, male first, female later. Both are types of sequential hermaphroditism, and both are completely, utterly normal in the fish world. But why? Why would evolution come up with this? Simple. It's efficient. In many fish species, a larger body means more reproductive success. For females, being bigger means carrying far more eggs, so if you're small, it makes sense to be male. Once you've grown large enough, flip the switch, go female, maximize those eggs. It's not random, it's not accidental. It's the fish equivalent of a strategic career move, except instead of a promotion, you get a completely different reproductive system. Here's how it actually works biologically. Fish don't have rigid sex chromosomes the way mammals do. Instead, sex is regulated by hormones and social signals. When a dominant individual is removed from a group, the hormonal environment shifts, stress hormones drop, sex hormones recalibrate, gene expression changes. Over days or weeks, the gonads physically restructure. A fish that was producing sperm starts producing eggs, or vice versa. The brain changes too. Behavior shifts. It's a full biological renovation, and the fish doesn't consciously decide any of this. The body reads the social situation and responds automatically. Nature is extraordinarily good at solving problems. There are over 500 species of fish known to change sex. Parrotfish, gobies, groupers, sea bream, the list goes on. Some species can even change back depending on circumstances. A few are simultaneous hermaphrodites, meaning they carry both sets of reproductive organs at the same time. The hamlet fish, for instance, will swap roles with a partner mid-spawning. They take turns, very civilized. Sex in the animal kingdom is not the rigid, binary, fixed thing we sometimes assume it is. For hundreds of fish species, it's flexible, functional, and shaped by environment. It evolved because it works. Because nature doesn't care about categories, it cares about survival. So next time you're standing at an aquarium, staring into a reef tank, just know, some of those fish have already lived multiple lives, changed sex once, maybe twice, outlasted rivals, restructured their entire biology, and they did it all without making a single big deal about it. That's Zoodoodle. Nature is stranger and smarter than you think.